You are built from the dead. Every atom heavier than hydrogen in your body was forged inside a star that no longer exists. One sun keeps you alive. So why did the universe build 200 billion of them in this galaxy alone, and 2 trillion galaxies beyond? By the end, you'll see why you needed every one of the dead ones, and why a single sun could never have made you. Start with the arithmetic, because it's absurd. You need exactly one star, the sun. It warms the planet, drives the weather, feeds every plant that has ever fed you. For everything a human life requires, one ordinary yellow star is enough. Now count what's actually out there. Our galaxy holds somewhere between 1 and 400 billion stars. Call it 200 billion. Each one a sun, many with planets, most with nobody to see them. And the Milky Way is one galaxy. The observable universe contains roughly 2 trillion of them. Multiply it out and you get a number with 22 zeros. More stars than grains of sand on every beach on Earth, by a factor of thousands. And nearly all of it is unreachable and useless to you. The nearest star beyond the sun is 4 light-years away, a distance no human will cross in a lifetime. The next galaxy is 2.5 million light-years off. For every practical purpose a human life has ever had, those 200 billion suns might as well be painted on the sky. They give you nothing. They warm nothing you touch. For one species on one planet that needs one star. If you wanted to design a universe for humans, this is not how you do it. It's the most oversized, overbuilt, wasteful-looking arrangement imaginable. A cathedral the size of a continent built to shelter a single candle dot. Unless the extra stars aren't waste at all. Unless you literally could not exist without the ones that already died. And that's not poetry, it's chemistry. You have held this fact in your hand without noticing it. Salt, sodium and chlorine. You put it on your food this week. It's on almost every table on Earth, so ordinary it's invisible. But sodium does not make itself. Neither does the calcium hardening a child's bones, or the iron riding in the blood through your heart right now, or the oxygen you just breathed. None of these can be built from nothing. And none of them could be made in the early universe, because the early universe was almost entirely the 2 lightest elements, hydrogen and helium, and nothing else. Think about what that means. 14 billion years ago, there was no calcium anywhere, no iron, no oxygen, no carbon. The raw material of your body did not exist. Not on Earth. Earth didn't exist either, but nowhere, in the entire cosmos. The very early universe cooked up hydrogen, helium, and a trace of lithium in its first few minutes, then stopped, cooling too fast to make anything heavier. For that it needed furnaces that hadn't been built yet. It needed stars. So every heavy atom in you was made somewhere, after the beginning, by something. Not in the Big Bang couldn't do it. The salt in your kitchen has a birthplace, and a birth date, and the birthplace is not this planet. It's the inside of a star, and the birth certificate is written into the atom itself, in a form astronomers can actually read in starlight. The factory that made you has a location, and the terrible thing about that factory is that it only runs when a star is dying. Here's what almost nobody stops to ask. We treat the sun as the source of everything, light, warmth, life, and for energy it is. But the sun did not make the atoms you're made of. Those were already old when the sun was born. The sun is a second-hand star, built from the ashes of earlier ones. We also assume, without thinking, that the material was just sitting here waiting, that Earth came stocked with everything a body needs. But the planet itself is made of the same second-hand atoms. The iron in Earth's core and the iron in your blood came from the same dead stars. The ground and the body share a birthplace. So the real question, the one that turns the whole thing inside out, isn't why so many suns for one species. It's this. How many stars had to live and die before a single human body was even chemically possible? How much cosmic history is folded into one heartbeat? The answer runs into the millions, and every one of them had to die on schedule for you to be here. So here's the sentence that flips the question completely. The heavy elements in your body were not made by the sun. They were made by stars that died before the sun was born, and the only way to make them was for those stars to die. Follow the machinery. Deep in a star's core, crushing gravity generates temperatures of tens of millions of degrees, hot enough to fuse hydrogen into helium. When the hydrogen runs low, the core contracts, heats further, and starts fusing helium into carbon. Bigger stars keep going, carbon into oxygen, oxygen into neon, neon into silicon, each stage hotter and faster than the last. This is nucleosynthesis, the universe's only furnace hot enough to build the middle of the periodic table, one element stacked on the last. But it stops at iron. Iron is the ash at the bottom of the fire. Fusing anything into iron gives energy. Fusing iron into anything heavier takes energy instead of releasing it. So when a massive star's core turns to iron, the fire has nothing left to burn. Iron is where a massive star's life ends, not with a fade, but with a countdown. When that iron core forms, the star has seconds left. Gravity wins, the core collapses, and the star explodes as a supernova, briefly outshining an entire galaxy. And in that explosion, in a matter of seconds, elements heavier than iron are forged and flung across space. The trace metals in your enzymes, some of the atoms in your own DNA. There's a second route, too, quieter than the explosion. Some heavy elements form when the naked cores left behind by dead stars, neutron stars, city-sized and unimaginably dense, spiral together and collide, flinging out gold and platinum in a single cataclysmic merger. The gold in a wedding ring may have been made in a collision of two stellar corpses. Either way, the rule holds without exception. The heavy stuff comes from death. Here's the first payoff, the thing the fossil of the periodic table has been hiding. You are not powered by a star. You are assembled from the corpses of stars. The calcium in your teeth was scattered by an explosion that ended a sun millions of years before ours ignited. Your body is a graveyard, reassembled into something that can read this sentence. But that only deepens the real mystery. Because if it takes a dying star to make you, it doesn't take one. It takes an almost unbelievable number of them. And that number is exactly why the sky is so crowded. Now the reasonable objection. Fine, you think, so we needed a few dead stars to seed the elements. A handful, maybe a dozen, not 200 billion. The number is still absurd. Take that seriously because the intuition is fair. And here is where the universe does something far stranger than the textbook summary suggests. It is not that a few stars politely donated their ashes and the rest are decoration. It's that the enrichment of a galaxy with heavy elements is a slow, statistical, galaxy-wide process that requires enormous numbers of stars over enormous time, because the vast majority of what stars make never ends up in you or in anything. Most stars are small red dwarfs that don't explode at all. They lock their material away for trillions of years and give almost nothing back. Of the stars that do enrich the galaxy, most of the enriched gas they scatter drifts into interstellar space and never forms a planet, never mind a person. The efficiency is brutally low. To end up with enough heavy elements concentrated in one place, a dust cloud rich enough to build rocky planets and living bodies, you need generation after generation of stars, hundreds of millions of them, cycling through birth and death across billions of years, gradually seasoning the galaxy. And there's a timing problem on top of the efficiency problem. The heaviest, brightest stars, the ones that explode and enrich, burn out fast, in a few million years. The small, dim ones last for trillions, but give almost nothing back. So the galaxy's enrichment depends on a relatively rare kind of star that lives briefly and dies violently. And you need vast numbers of them firing across billions of years to slowly raise the whole galaxy's chemistry to the point where a rocky, iron-cored, life-capable planet can even assemble. The Sun is roughly a third-generation star. Before it could form with a planet capable of chemistry, the Milky Way had to be enriched by everything that came before. And that enrichment is a numbers game played across the whole galaxy. 200 billion stars isn't the universe being wasteful. It's the minimum batch size for a process this inefficient to produce even one habitable world. Which means the crowded sky isn't excess, it's a receipt. And to feel what that receipt actually cost, you have to stand inside one of these deaths. Put yourself in orbit around a massive star, 8 times heavier than the Sun, in the last day of its 10 million year life. You've been watching it for what feels like forever. For millions of years it burned hydrogen, calm and bright, a steady blue-white lantern. Then, faster, helium, then carbon, and now the pace is terrifying. What took millions of years now takes centuries, then months, then days. The star is racing towards something, and it cannot stop. Watch the core. It's building shells like an onion, hydrogen fusing on the outside, then helium, carbon, oxygen, silicon, each layer burning faster than the last. The silicon shell ignites, silicon fuses into iron, and here the clock breaks. What took the star 10 million years now takes a single day. Iron floods the core, then 1 second. In 1 second, the iron core, larger than the Earth, collapses to the size of a city. The outer star, still falling inward, slams into the incompressible core and rebounds. For a few seconds, this one dying star shines brighter than the 200 billion around it combined. And in those seconds, the explosion cooks and scatters a spray of new atoms into the dark, gold, iodine, the iron for 100 million future bloodstreams. Then the star is gone. Where it burned for 10 million years, there is now an expanding cloud and a collapsed remnant. Now widen the view, because this is the part that matters. That single death was not enough to make you. Its ashes are a contribution, not a completion. Mix them into the interstellar gas, and you've raised the heavy element content of that gas by a vanishing fraction. To build a place rich enough for planets and chemistry, this exact event, a massive star living, dying and scattering, has to happen again and again across the whole galaxy for billions of years, each explosion adding another trace to the mixture. That cloud will wander for millions of years. Most of it will scatter into nothing, but a thread of it, one part in a vast number, will someday drift into another collapsing cloud and become part of a new star and a new planet, and eventually the marrow of a bone. The odds against any particular atom completing that journey into a living body are staggering. And yet, you are made entirely of atoms that beat those odds. Every single one. Sit with the strangeness of the timescale. The star you watched die spent 10 million years building the atoms, 1 second collapsing and a few seconds scattering them. Then those atoms drifted in the dark for longer than the star was ever alive, waiting, inert, for a chance that might never come. Most of them are still waiting, somewhere out there, and always will be. The ones in you are the lucky exceptions that found a home. So here's what I keep turning over. If it took the death of countless stars to build a single human being, does that make you cosmically precious or cosmically accidental? And can it somehow be both at once? Because the deaths that built you weren't a one-time event. They're a chain, and you are only the latest link in something 11 billion years long. Hold that dying star in your mind, and let's understand exactly what it did in 3 layers. Layer 1. What it feels like. A star is a bomb and a wall, balanced. Gravity is the wall, forever crushing inward. Fusion is the bomb, forever pushing out. For most of a star's life, these two are perfectly matched, and the star just sits there, burning, stable. A star is what a controlled explosion looks like when it lasts 10 billion years. Death comes the instant the bomb runs out of fuel. The wall never tires. The moment fusion falters, gravity finishes what it always intended. Everything a star ever built, it built while dying by degrees. And the size of the star decides everything about its death. A star like the Sun will never explode. When its fuel fails, it will swell into a red giant, shrug off its outer layers gently, and settle into a slowly cooling ember. It makes carbon and oxygen and hands them back softly. Only the giants, stars many times the Sun's mass, reach the temperatures needed to build all the way to iron and then detonate. So the heaviest elements in you came specifically from the rarest, most massive, most short-lived stars. The universe's most violent deaths wrote the most intimate parts of your chemistry. Layer 2, the mathematics. There's a single relationship at the heart of this, and Einstein wrote it. E equals mc squared. Energy equals mass times the speed of light squared. In human terms, a tiny amount of mass can become an enormous amount of energy, because c squared, light speed multiplied by itself, is a gigantic number. When 4 hydrogen nuclei fuse into one helium nucleus, the helium weighs slightly less than the 4 that made it. Not much, about 0.7%. That missing mass didn't vanish. It became energy, sunlight, warmth on your face, following E equals mc squared. Every second, the Sun converts about 4 million tons of its own mass into energy this way. 4 million tons a second, and it barely notices. The Sun is so vast, it has done this for 4.5 billion years and is only middle-aged. That is why stars last so long. The fuel is mass itself, and c squared makes a tiny sacrifice of mass pay out an enormous return of energy. That single equation, mass into energy, is why stars shine, why they endure for billions of years, and why, in their final moments, they can build the elements that build you. Layer 3, what it says about reality. This is not an interpretation, and it's worth being precise. The broad picture of stellar nucleosynthesis is settled, tested science. We can see it directly. Split the light of a distant star through a prism, and dark lines appear at exact wavelengths, the fingerprints of specific elements, each one announcing its presence. Meteorites carry the same signatures frozen into rock. The theory predicts precise proportions of elements, and the sky delivers exactly those proportions. This is one of the best confirmed stories in all of science. What remains debated is the fine detail, precisely which explosions make precisely which heavy elements, and in what ratios. The gold in a wedding ring may come from colliding neutron stars rather than ordinary supernovae. That part is still being worked out. But the headline is not in doubt. You are made of star stuff, and star stuff is made by dying. The cost, stated plainly. Complexity has a price, and the universe pays it in stars and in time. To go from a cosmos of pure hydrogen to a cosmos containing one creature that can wonder why. That took roughly 9 billion years of stellar life and death before the Earth even formed, and another 4.5 billion after. The crowded sky is the ledger of that transaction, written in light. And this reframes the entire question you started with. You imagined a universe that built far too much for one small need. But there was no smaller version available. A universe with only one star makes no heavy elements, no planets, no chemistry, no observers. Just a single ball of hydrogen burning alone in an empty void, forever, with nobody to see it. The choice was never 1 star or 200 billion. It was 200 billion stars, or nothing that could ask the question. The abundance isn't generosity or waste. It's the entry fee for a universe that contains anyone at all. Take that idea, complexity paid for in stellar death, and run it across every scale. At the scale of a single atom, consider 1 atom of oxygen, right now, on its way into your lungs. The oxygen atom you are breathing at this exact moment was made in the core of a star that died before the sun existed. It has been part of a nebula, a comet, an ocean, and countless other bodies before yours. You do not own your atoms. You are renting them from the dead, briefly, and you will return every one. At the scale of your body, you contain roughly 7 billion atoms. The iron in your blood alone came from supernovae. If you gathered it all, it would be a small nail's worth of metal, and that nail was forged in explosions across multiple dead stars. The calcium in your skeleton, the phosphorus in your DNA, the sodium firing along every nerve as you understand this sentence, all of it stellar ash. You are not a thing that formed once. You are a confluence, trillions of separate stellar histories meeting for a few decades in the shape of a person who can think about the stars that made them. There's a humbling consequence hiding in that. The atoms don't belong to you, and never did. They were oxygen in someone else's ocean, carbon in some ancient forest, iron in a meteorite, long before they were briefly arranged as a person. When you die, every one returns to circulation, to be soil and sea, and someday, perhaps, another body. You are a temporary pattern, not a permanent substance. At the scale of the galaxy, the Milky Way is a recycling engine. Stars form from gas, forge elements, die, return enriched gas, and the next generation forms richer than the last. You live in a galaxy that has been slowly composting itself into complexity for over 13 billion years. Every generation of stars is topsoil for the next. At the scale of the universe, this can only happen for a while. Star formation across the cosmos peaked around 10 billion years ago and is now in long, permanent decline. The raw gas is slowly being locked up in dead remnants and never returned. There will be a last star, trillions of years from now, and a last supernova, and after that, no new heavy elements will ever be made again. The periodic table finished forever. You exist inside the fertile window, late enough that generations of stars had time to build the atoms in you, early enough that the lights are still on and the sky is still full. Miss that window by a few tens of billions of years in either direction, and there is no you. The same law at every scale. Complexity costs death and time and staggering numbers. Which brings the whole enormous accounting back down to something you can hold, a single breath. Pull it all the way back in, from 2 trillion galaxies to the air in your lungs right now. Take a breath. Hold it a second. In that lungful of air are atoms of oxygen and carbon that were each manufactured inside a dying star, scattered across light years, drifted for millions of years, and have now, briefly, become you. Here's the promise I made you at the start, paid off. You asked why the universe built 200 billion suns when you only needed one. The answer is that you did not need one. You needed all the dead ones first. The single sun you depend on for warmth could never have made your body. It can't even make the elements you're built from. Those required generations of earlier stars, and those required a galaxy full of them, and that galaxy required billions of years. So the sky is not oversized. Read it correctly, and it's exactly the right size. The minimum a universe needs to turn hydrogen into a creature that can look up and ask the question. The 200 billion suns are not extras crowding around your one necessary star. They are your ancestors. Not metaphorically, chemically. Most of them had to live, and a great many had to die on time, in the right order, scattering the right elements into the right clouds, for the atom of calcium now sitting in your jaw as you listen to this. Change that history. Remove a few 100 million of those deaths, and the atom isn't there, and neither are you. There's a quiet dignity in that inversion. The old feeling that a human being is a speck lost in an indifferent immensity gets the accounting backwards. The immensity isn't what dwarfs you. The immensity is what it took to make you. Every one of those distant, useless-looking suns is part of the reason there is a you here to feel small in the first place. You are not a small thing in a big universe. You are what a big universe costs. And here the physics runs out, and the harder question begins. Is a universe that spends 200 billion stars to make one thinking creature extravagant beyond reason? Or is that simply the price of the thing, honestly paid? A believer can look at this and see a creator patient enough to work across 11 billion years and 100 million stellar deaths to arrive at a being who could finally notice. A skeptic can look at the identical facts and see no intention at all, only physics grinding forward, and one of its rare products being a mind briefly capable of mistaking itself for the goal. The chemistry does not decide between them. It only tells you the cost was real. What isn't in doubt is stranger than either reading. Every heavy atom in you was made in a place you could never survive, by an event that would vaporize you in an instant, in a star that died so long ago its light has already faded from every sky in the universe. You will never see the stars that made you. They were gone before the sun was lit. And yet they are not entirely gone, because a fraction of each of them is here, reading this, in the only form that can look back at the sky and understand what it's seeing. You are the universe's way of keeping those dead stars, for a while, in a form that can love and fear and wonder where it came from. When you look up at those 200 billion suns, you are not looking at strangers. You are looking at the furnaces that made your hands. They died, and here you are, breathing them. If that leaves you wondering what set the whole furnace burning in the first place, the next question is waiting. What existed before the universe? It's on your screen now. You are built from the dead, and you are still warm.